If you're a student or beginner trying to understand IT, information systems, or programming without the confusing jargon, welcome to LD Tech Lab. Make sure to subscribe, and let's break this topic down step by step.
If your Java program compiles, runs, and still produces the wrong output, this video is for you. Many beginners believe that once there are no red errors, their program is already correct. Unfortunately, that belief causes more confusion, frustration, and failure in programming. In Java, a program can compile perfectly, run smoothly, and still be completely wrong. This usually happens because Java follows logic very strictly. It does exactly what you tell it to do, nothing more, nothing less. In this video, I will show you the most common Java mistakes that compile, run, and still fail. More importantly, I will teach you how to think like a programmer instead of memorizing syntax. Let's begin with a mistake that looks harmless but silently breaks your program logic. In Java, local variables must always be initialized before they are used. Java does not guess values, and it does not automatically assign numbers just because you expect it to. Look at this example carefully. Int total. If x greater than 5, total equals 10. System.out. Println, total. At first glance, this code looks fine. However, notice what happens if the condition x greater than 5 is false. In that case, the variable total never receives a value, yet the program still tries to print it. Even if the program compiles, the logic is broken because the variable does not always hold a valid value. This leads to unpredictable behavior or compiler complaints depending on the context. The correct approach is to always give your variables a safe initial value. Int total equals 0. If x greater than 5, total equals 10. System.out. Println, total. A program can compile and still be logically invalid. Next, let's talk about one of the most common reasons Java programs crash at runtime. Arrays in Java always start at index 0. This means the first element is at position 0, not 1. Beginners often forget this detail and accidentally allow the loop to run one step too far. For int I equals 0, I less than equals arranged by length, I++. System.out. Println, I. The problem here is the condition I less than equals arranged by length. When I becomes equal to arranged by length, Java tries to access an index that does not exist. This causes a runtime error, even though the syntax itself is correct. The fix is simple, but understanding it is important. For int I equals 0, I less than arranged by length, I++. System.out. Println, I. Runtime errors come from logic mistakes, not syntax. Sometimes, a single symbol can completely change how your program behaves. In Java, assignment and comparison are not the same thing. If x equals 5, system.out. Println, true. Here, the variable x is being assigned the value 5 instead of being compared to it. This changes the value of x and breaks the logic of the condition. What you actually want is comparison. If x equals 5, system.out. Println, true. Java will never assume your intention. It follows your instructions exactly as written. Programming is precision. A very common beginner question is, why does 1 plus 2 become 12 in Java? The answer lies in data types. System.out. Println, 1 plus 2. Because 1 is a string, Java switches from arithmetic to string concatenation. Instead of adding numbers, it joins text together. If you want mathematical addition, both values must be numbers. System.out. Println, 1 plus 2. If you want to combine text and math, you must control the order. System.out. Println, sum, plus, 1 plus 2. Data types control behavior. Many students memorize Java syntax, but struggle the moment the problem changes. They know how to write a loop, but they do not understand why it works. Instead of memorizing code patterns, you should ask logical questions. Where does the loop start? When should it stop? What changes each time it runs? Programming is not about typing keywords. It is about understanding the flow of execution. Think in steps, not keywords. Errors are not the enemy. Ignoring them is. When beginners see this message, null pointer exception, they often panic or ignore it. Instead, debugging starts with asking the right questions. Which variable is null? Where should it have been initialized? Why was it never assigned a value? Debugging is not optional in programming. It is part of the job. Most beginners believe that their main problem is Java syntax. But syntax is not the real issue. Logic flow is. Programming is about decision making. What happens first? What happens if the condition is false? What code runs inside the loop? Java follows logic, not intention. Programming is decision making. Remember these key ideas. Compiling does not mean correct. Logic matters more than syntax. Errors are teachers, not enemies. Debugging is a required skill. Understanding always beats memorization. If you are learning Java and struggling with logic, subscribe. I teach Java the way schools don't, focused on real understanding, not memorization.
If this video helped you understand the topic better, please like, subscribe to LD Tech Lab, and comment below what you want to learn next. Your questions help shape future lessons.